In this video, I want to talk to you about Cavalieri's principle for volume. Okay, so Cavalieri's principle says that if two three-dimensional figures have the same height and have the same cross-sectional area at every level, they have the same volume. Doesn't mean only two, they can also have like three, so it's okay with that. So basically it's saying, so you notice here, this one is like straight up, this one is slanted, which is called oblique, and this one right here is also straight. So if they have the same height, which they all do right here, they all have the same height and the same cross-sectional area at every level. So what is a cross section? Basically just means it intersects your solid. See this plane right here? It just like cuts it, slices right through it. So if you have any level of that, if those areas are equal, they all have the same volume. Okay, so in other words, just if your solid is oblique, like slanted, tilted, you're still going to use the same volume formula because it will have the same volume, they have the same height and the same area of the cross section. So let's actually show you one. So let's see here. According to Cavalieri's principle, all three of them, all these three shapes should have the same volume, because you should have the same height and all the area of their cross section should be equal. So let's do one area at a time. So this one looks like it's like a rectangle, so the area is length times width. So for the first one, you'll have 3 times 2. So the area of the first prism is going to equal to 6 centimeters squared. The next one is not a rectangle because you don't have the 4 right angles, but just looks like a parallelogram. So this formula, the area of a parallelogram is just going to be base times height. It's just kind of area equals 3, the base, times your height, which is 2. So my prism, 2, the area is 6 centimeters squared. And the last one is a triangle. The area of a triangle is half of your base times height. So the base here is 6. And then my height here is 2. If I do half of 6, that's 3. 3 times 2 is 6. So again, 6 centimeters squared. So that's basically Cavalieri's principle. So because all the areas of the cross section are the same and they all have the same height, then all their volumes are going to be equal. So will the volume of these two stacks of CD, will it be equivalent? Justify your answer. So look at this stack of CD and this one. Will they be the same? Well, the answer will be yes. And the reason is because they have the same number of CDs. So the same number of CDs means it's like the same height. And their cross section will be the same based on Cavalieri's principle. So for here, we're going to say yes. They have the same number . Okay, they have the same number of CDs, so they have the same volumes, the same height. So basically, if you have like a prism like this and one is oblique, like it's slanted, they'll still have the same volume. It's still the same height. It's just like shifted. Okay, that's basically it. Let's do example 1. Find the volume of the cylinder. Give your answer in terms of pi and rounded to the nearest tenth. So keep that in mind in terms of pi and rounded to the nearest tenth. So this is my cylinder. It's oblique because it's like tilted. But my volume of the cylinder, we're still going to use the same formula because remember, based on Cavalieri's principle, even though it's that way, you still can use, it'll be the same volume as the right cylinder. So the volume is your pi r squared, so the area of your base times your height. So here, let's just make sure we have our radius, which is right here, it's 8. So it's 8 squared, and then my height is 12. So remember, I have two answers, one round to the, in terms of pi and one to the nearest tenth. So first let's do in terms of pi. So I do 8 squared, which is 64. So now because I want in terms of pi, my answer should have pi in it. So I will not multiply the pi out. So I'm just going to multiply 64 times 12 and you'll get 768 pi, my units, centimeters cubed, so the volume. that's one answer. And if you wanted to find the nearest tenth, like in a decimal form, now you can just do 768 times pi, you'll get your decimal. And then all you have to do is round to the nearest tenth, so it's one decimal place. So that will be 2,412.7 centimeters cubed. All right, so as you can see, we still use the same formula for volume for a cylinder. Okay, example 2. Columbia Records unveiled the LP, a vinyl record, in the Waldorf Astoria on June 18, 1948 in two formats, 10-inch in diameter, matching that of 78 RPM singles, and 12 inches in diameter. If the thickness of one vinyl record is 0.112 inches, then determine the difference in volumes between the 10-inch and 12-inch records. Okay, so let's go ahead and underline what's important here. We have a 10-inch in diameter, and we also have the 12-inch. So the thickness of one vinyl record is, that's important. So the thickness, that's important to know. And what are we trying to find? Determine the difference in volume between the 10-inch and 12-inch records. So this is a stack of all those vinyl records. So the shape looks like a cylinder, an oblique cylinder, but still a cylinder. So we're going to find the volume of each one and then find the difference of them. And notice here, so it's one record, right? But now they're all stacked up with 15 of them. So you want to find the volume of one stack that has 10-inch diameter and the other stack of 15 records with a 12-inch diameter. So let's get started. So we have the 10-inch diameter. Okay, so that means if our diameter is 10, our radius is going to be 5, and now I'm going to use a volume of a cylinder. Substitute in. My radius is 5 squared, and the height is given. And now we go ahead and do your exponents. Do 25 times, and then your answer will be 8.796. Keeps going. I'm rounding to nearest 100, so it'll be 8 so it's 80. I'll just leave it as 8.8. What an ugly 8. Okay, so that's inches cubed. So that's just for one. We need 15 records. We need to include the stack. So with the stack, we'll have 15 times that one volume. So that means my volume is going to equal, when you multiply 15 times 8.8, you're going to get 132 inches cubed. So that's for the 10-inch. Now we're going to go ahead and do the 12-inch diameter. So that means my radius is half of the diameter, so that's going to give you 6. And we're still going to use the same formula and just substitute in 6 instead. That's different. So do your exponents, then multiply it out. So your volume is going to equal to 12.669, blah, blah, blah. So I'm going to round to the nearest 100, so it'll be 12.67 inches cubed. So that's one, but there's 15 of them, so let's include the stack. So that's going to give you 190.05 inches cubed. And now, remember, answering the question, find the difference. So for the difference of the volume, we're just subtracting them. we're going to go ahead and do 190.05 minus 132. So the difference in volume will be 58.05 inches cubed. All right, and last but not least, number 3, the example. Determine the volume of the tilted prism if the dimensions are the length is 43 inches, the width is 92 inches, and the height is 4 feet. Let's go ahead and label what we have. So the length is 43 inches, the width is 92 inches, and the height is 4 feet. Notice feet, and that's in inches. I don't want that. I want them all in the same units. They didn't really specify what to convert to for final answer, but if I have 2 out of the 3 that are in inches, I might as well just convert this one to inches. That way I have less work to do. So keep in mind that 1 foot equals 12 inches. So if you want to know in 4 feet how many inches is that, all you're doing is multiplying. So 4 times 12 will give you 48 inches. If you want a visual, because I have a proportion, look, 1 feet is 12 inches. So let's make a proportion. So if you have 4 feet, how many inches is it equal to? So that's basically what you're doing, and you would like cross multiply. So you'll have x equals, and then that's how you do 4 times 12, and that's why it would be 48. Okay, but you don't have to do that. If you see it, just go for it. So now they're all in inches, so wonderful. Let's go ahead and use our formula for the prism. The prism is length times width times height. So just substitute your values because they're all in the same units now. So we have 43 times 92 times 48. So the volume in inches will be 189,888 inches cubed. Now let's say you have to have your answer in terms of feet. Doesn't mean you have to redo all of this and convert each one to feet. Whatever your final answer is, we can convert it to feet. So let me just show you how to do this. And I'll have more details on that like later when we on the video on like similar solids, because all with scale factors, it's similar to what I'm going to do here. So let's keep this in mind. This is inches cubed. So we said that 1 foot is equal to 12 inches. So if I want to know how much feet this will be in, I have to put it under the inches. But notice it's inches cubed. I want this to be inches cubed so it could be the same. So here's just inch, trying to find an inch, 1 foot, and then 4 feet with to the first power. So if I want it cubed, I will cube both sides because we're dealing with volume. So really I'll have 1 foot cubed equals, so you're doing 12 cubed, which will give you 1,728, and you have to do the inches cubed. So now that we're all in the same units, you can still do the cross multiplying. So you want to know how much feet would be for that, for 189,888 inches cubed. So I'll put the inches underneath, because it's inches cubed. Now I want to know how much feet cubed it is. So that's why we have to put it in cubed. And then boom, cross multiply. So you'll just have 1 times that, so it's the same thing. And then cross multiply here. So you'll have 1,728 times x. So if you wanted to solve for x, you're going to divide. So that means x in terms of feet, that'll give you approximately 109.89. So the volume for feet will be 109.89 feet cubed. Now because it didn't specify, I would just left it in inches, just to show you that if you do have to convert it, if your answer is in cubed or squared, make sure you do that also too with your units over here. Okay, and that's how we could apply Cavalieri's principle to all these problems that we just did.